Hi and welcome. I'm glad that you are here. You have taken the first step to extend your skills. That's great. I will guide you through this journey. Take your time, have fun exploring, and keep in mind, learning is a continuous process. Let's get started. Hi, my name is Andreas. I'm the founder of Chrysler IT Services and I'm a LabVIEW architect. I will be your trainer for this course. With over 15 years of experience, I helped many customers solve their challenges in the test and measurement area. My goal is to motivate you and inspire you to learn quickly, solve your challenges, and enjoy the process. This is how we structure our trainings. We at Chrysler IT Services provide high-quality training and consulting services. Every trainer brings over a decade of expertise. We provide targeted off-the-shelf trainings, but also very highly customized ones. Our fields are LabVIEW, Python, TestStand, and Diagram. In this section, we will talk about Nigel, the new AI advisor, which is integrated in LabVIEW 2025 Q3. It helps us understand, write, and debug our LabVIEW code. Let's get into it. I prepared a simple project here in LabVIEW 2025 Q3 with a simple VI that just creates a text file. And here in the menu bar, you will realize that there is a new icon, Chat with Nigel AI Advisor. Maybe if the window is too small, it could happen that you do not see this icon. So make sure that the window is big enough and you will see this button here in the block diagram and also in the front panel. So let's click on this icon to start Nigel. Another reason that you do not see this icon could be that you haven't installed it. So when you install LabVIEW, you have to make sure that you also tick the option that you want to have Nigel, if you want to have Nigel. If you start Nigel the first time, you will be asked to log in. So you have to use your email address where your LabVIEW license is associated with. I already did this on my machine, so we are ready to interact with Nigel. So let's ask him a basic question. What is a cluster? And hit enter. Let's wait for the response. A cluster in LabVIEW is a data structure that groups multiple elements. Yeah, sounds good. Mixed data types, fixed elements, and there are access methods like bundle and unbundle by name. And on the front panel, it appears as a labeled container. Yeah, so that's a great response. And I think especially when getting started with LabVIEW and learning it, it could be a nice assistant asking questions about basic stuff and getting familiar with the concepts. So let's increase the complexity and ask Nigel how can we read a CSV file. Hit enter. So we get a step-by-step approach. You can read a CSV file in LabVIEW using the read delimited spreadsheet VI, which is correct. And here we get the step-by-step the things that we need to do, like wiring the file path, setting the delimiter input, specifying the format, and handling the output. And if we scroll down here a little bit, we also get a kind of a flowchart that shows us how to implement the code. And down here, we get some additional detailed tips. We can even discuss our VIs with Nigel. Let's try this out. Open up the context help using Control H or picking on the yellow question mark. Then hover over the icon of the VI that you want to discuss with Nigel. I will want to discuss the Debug Window VI with Nigel. So let's click on Discuss with Nigel in the Context Help window. Let's wait a second till Nigel is loading up. So we see that the screenshot of the VI gets loaded into the chat with the command describe VI. So it takes a while and now we see the response from Nigel. This VI generates a specific number of random values, multiplies each by a user-defined factor and writes the result to a text file, which is correct. So it did the analyzing very well. If we scroll down a little bit, we see a description of the controls and indicators, like the samples, the multiplier. It gives us the actual values, so it passed it correctly, and a short description for the controls and indicators. So what do you think about Nigel, the new AI advisor in LabVIEW 2025 Q3? Do you think you can integrate it in your LabVIEW workflows in the future? We tried a few things out. We can ask basic questions, we can even ask more complex ones, and we can also interact with our existing VIs and let us describe the code. That is pretty awesome so far. I am looking forward into the future. Let's see what will happen next. In this section, we will have a look at the new debug window. It's a great thing. It combines the probe watch window and the breakpoint manager. Let's look into it. So we already opened LabVIEW 2025 Q3. We prepared a small demo project here to demonstrate the new debug window. So let's open this VI and navigate to the block diagram. And first thing is we can press Ctrl D to open up the debug window. This is already a big benefit. In the past it happened very often that we probably lost the probe watch window and it was hard to find it when a lot of windows were open. So that makes it very easy. We can just press Ctrl D to bring back the debug window to the front. So let's create some probes and some breakpoints. We could do a right click here on this arrow wire and add a breakpoint. You see it automatically gets added down here in the debug window. We can add another breakpoint here at the end, for example, right click on the arrow wire, add breakpoint, and we see another breakpoint coming up in our debug window. So when we run our VI, it will automatically pause at this specific location so that we can do further debugging. Let's also create a probe to see the live value of a wire. We can, for example, add one here, right click on the output of the multiplication, add probe, and let's add another probe here for the string, right click, add probe. You see down here, it gets added to our debug window. So this is actually very comfortable that now breakpoints and also probes can be managed within the same debug window. Another nice benefit is that we can rename the breakpoints and also the probes to make it easier to identify them. So we have the numbers, we can identify it by the number. We can also do a double click on the breakpoints and on the probes to identify them. And to rename them, we can do a simple right click here and choose rename. So we could call that, for example, break after file open. And we could also rename the second one here, right click, rename, and this is break before file close. Yeah? So that's pretty handy and it makes it a lot easier to identify the breakpoints and the probes in our code when we are debugging. So for a good overview, let's also rename the probes. So the probe 8, for example, could be string file output, and this probe here could be the numeric result. So perfect. Yeah? By double clicking we can also easily identify them. Let's look through the context menu again together. Right click either on a probe or on a breakpoint gives us the option to highlight the wire, so that would be like double clicking. You can also open the probe in a separate window, so you get a small additional window that you can arrange as you want to see the value then when you execute the block diagram. We can remove the probe or the breakpoint, we can copy the actual data, we can export the data to the clipboard, and as we already did, we can rename the probe or the breakpoint. And what we can also do is we can combine a probe and a breakpoint. Yeah? So this probe could actually also be a breakpoint if we click here on add breakpoint. It would be visualized like that. So in general, the yellow icon represents the probe, the red dot represents the breakpoint, and the yellow dot surrounded with a red circle represents it's a combination of a probe and a breakpoint. So we defined our probes and our breakpoints, and now let's execute the VI together. Click on Run or Ctrl R to execute the VI. You see that it immediately gets paused as it hits here the first breakpoint, which is break after file open, and now we could go on with single stepping and the other debugging tools that we know. We see that the probes, string file output and numeric result are not yet executed, which makes sense as we stop the VI before we entered the for loop. Now we could do next step and step into the for loop, and then the VIs get executed step by step until we reach our probe. And now you see that the numeric result probe got updated. And now if we continue executing our VI, we also see that now the next probe is also updated. And we also see the live value of the probe here on the wire, which also makes debugging a lot easier. We can continue again, so the loop restarts. We will not do that till the end now, as it's multiple iterations, so we can just finish the for loop. After the for loop is finished, we see that we do a pause again, because we hit here the next breakpoint, which is the break before close. So we can do further debugging and then finish our VI. There are some settings that we can adjust here for our probes and breakpoints. For example, let's choose the string file output probe here and click on the small gear icon here. So we can either hide the probe display. This could probably make sense if we have separate small windows for each probes. Then there is the option to keep window on top. I guess it would always make sense to keep it on top to not lose the window. And there is another option that we can toggle, which is show values on wires. We saw that previously, the small blue label that popped up when executing the VI that showed us the live value of the wire. We can either enable or disable that with this selection. There are additional settings that we can choose for our probes. As we saw previously, we just used the default probe that shows the live value that is actually present on the wire. By selecting a probe, you can click here on this gauge icon here, and you can change actually the type of the probe. You probably are aware of the history probe, for example, which is pretty nice. It gives you all the values that occurred on this wire since the VI was started. That's actually pretty nice. So we can restart the VI here to have a look, and let's execute the for loop a few times here. And you see here now in the probe display that we get all the previous wires and the latest wire. So that's the probe with history. That's pretty handy. And there are a lot of other types that you can experiment with. For example, there is toggling the execution highlighting, which enables here the light bulb to execute the code slower. You can either enable this or disable this. For example, for code segments that are time related, you should probably switch it off. And for other stuff where you are just doing algorithms, you can probably switch it on to see what is going on your wires. Another great feature for probes is that you can actually make them conditional. So let's select the numeric result probe and click here on the gauge icon again, and you can select here conditional. So we have some options here. If we switch to condition, we can make it equal to, greater than, or less than, for example. So with that approach, we could define that if the random number in this case, for example, is bigger than 0.6, then we could break and pause our code to do further debugging. That's actually pretty handy. You could also do that for strings as well and make it conditional and check if the string contains specific data, and then based on that you will break your code to pause it to do further debugging. I hope you like the debug window as much as I do. I think it's a great opportunity to combine these probes and the breakpoints. It just makes our debugging life a lot easier. You will find this VI that I used for demonstration also below the video, and you can download it and try things out. In LabVIEW 2025 Q3, we have a new feature called Log Unwired Errors. This will probably make our debugging life easier in the future, as it automatically logs potential errors that occur into a text file when the error is not handled. And this even works if automatic error handling is not enabled. Let's look into it. So I prepared a demo project with a simple VI that will produce an error. And to activate this new feature, go to Tools, Options, Block Diagram, scroll down a little bit, and here you find the new option Log Unwired Errors. The default path is the user path Documents, LabVIEW Data, and the folder is called Unwired Errors. And inside there, we will see then our text files. You can click on Explore to open up the Windows Explorer. I have that already open on my side. And you see here that the text file will get produced with a timestamp. And if you start LabVIEW again, you will get a new log file. So whenever in your LabVIEW programs errors occur, they will automatically be logged inside this file if they are not wired or handled. This is independent of the automatic error handling setting. No matter if this is on or off, your unhandled errors will be logged into this text file, and this can be actually very useful for debugging in the future. Should make our life easier. So we enabled the option and then click OK. And yeah, let's execute our VI. This should produce an error. Hit run. You see that we also get here the error message in the environment because automatic error handling is enabled. So I can click continue and the VI is done. And if we now go into our Unwired Errors folder, we can open up this text file here. And if we scroll down a little bit to go to the latest error, we see here that the error occurred. Open, create, replace file, produce the error, and the path is empty or wrong. So that's great. So this hopefully helps us in the future to identify our bugs easier. In this section, we will talk about the enhancements of the LabVIEW context help. Let's get into it. When we build sub-VIs in LabVIEW, the default setting is that the execution mode is non-reentrant. We can check that by right-clicking a VI, going into the VI properties and selecting execution in the drop-down, and here you see the mode. So the default is non-reentrant execution. That means that the VI can only be in memory one time, even if we use it multiple times in our code. If we want to speed things up and if our code can be executed in parallel, we can do so, but we have to make a change to the execution mode. We have to set it to pre-allocated clone. So I prepared a VI here that does some simple calculation, and I set the mode now to pre-allocated clone, reentrant execution. And the thing that actually changed is the description in the context help. If we save this VI now and close it, with Ctrl H, I can open up the context help, or by clicking the yellow question mark in the menu bar. And if I now hover my sub VI, I will see down here a note that tells me that this VI is reentrant, pre-allocated clone, and it also gives me information about the execution priority. That is very nice, so I can immediately see if a VI is reentrant or non-reentrant. In the past, we had to deal with that on our own to either add it manually to the VI documentation, or sometimes people also added maybe an icon in the header to make it clear that this VI is a reentrant execution VI. So this is a very nice feature, so we can easily identify the execution mode. In this section, we will talk about the LabVIEW Compare tool. It got updated a lot in the last few LabVIEW versions, but today we want to focus on the feature that we can actually use it via the LabVIEW CLI, so we can automate the Diff report generation, which is very nice. Let's look into it. So let's have a look at the LabVIEW Compare tool. What is it and what things have changed? So it's actually a tool that NI provides in addition to your LabVIEW environment to be able to diff the changes between revisions of VIs. So if you program your applications, things change along the way, and probably you want to know what have changed from now till last week. And you can use the LabVIEW Compare tool for that. And a lot of things have changed in the last few versions, so it got improved by a lot. So here we see a screenshot of a diff of 2 different versions, and we see that the code that actually got changed is highlighted. Like you see here, this Boolean constant that got added. Below in the small window, you see the changes described with text, which things have changed. A new feature, for example, is that you can now easily switch between the changes with your arrows on the keyboard. And it's also now easier to disable the cosmetic changes. So if just wires were moved a little bit, you can disable that and you will not see it in your diff. Here, for example, you see that we can now create the report out of these diffs. That's also pretty nice because you can create an HTML file here, which you can actually then see in the browser. So this could make code reviews very handy in the future because you do not have to open LabVIEW necessarily. You can just open up the HTML file in any browser and review the changes there. Here, for example, you see a small VI. This sub VI that got highlighted in green was added to the code, so that's the actual change. And we see some text descriptions and the screenshots. So what is actually new in the latest LabVIEW version, LabVIEW 2025 Q3? We can now create this HTML report using the LabVIEW CLI. That's very interesting because then we can use this to automate our workflows. So let's imagine that you have a repository in GitLab, for example, and as soon as you're checking in code, probably a pipeline gets started and tests your code, analyzes your code. Then you can add this CLI step in the future that creates the report for you. And then you can later on easily view the changes in the browser, and you do not necessarily have to start LabVIEW to do code reviews, for example. Here on this slide, we see some report types that are supported. You can either do an HTML file and have the resource files like the pictures separately, or you can also merge it into a single HTML file, which I think is the most convenient way. And you can also create a Microsoft Word file, plain text, or XML. And you also see some arguments down there that you can use, for example, to exclude block diagram cosmetic differences, for example. And with some tweaks, it would be also possible to add this report at the end into your GitLab environment, so you can easily view your differences of your LabVIEW applications inside your browser. That's pretty nice. So let's check it out how this works in action. I prepared a demo project here, which is a Git repository. I added a LabVIEW project here and made some changes and committed it, made some further changes and committed it again, so that we can use the compare tool to show the difference between the revisions. And we will use the LabVIEW CLI for that. So the LabVIEW compare tool actually needs physically two VIs, so version 1 and version 2. So we have to find a way how we physically get the same VI 2 times on the machine with different revisions. So what I did for testing purposes is I checked out this repository again with the previous commit. And here we have the latest version. So I have 2 separate paths with the same VI, which is the test TDMS API VI, but 2 different revisions. That's an important thing. And this could be also automated with scripts that you generate copies of your code to be able to compare them afterwards in an automated way. So the LabVIEW CLI got a new operation name in LabVIEW 2025 Q3, which is called Create Comparison Report. Then we have the argument for the first VI, so the full path to the first VI, and then the full path to the second VI. Then we can define the report type. I have chosen the HTML single file, and then we need the report path. So that's where we at the end will get our HTML file. So I will execute this command. This will take a while now till the report is generated. Then we will soon be back and have a look at it together. So now the CLI command is finished, and then we see here our HTML report got generated. We can double click it to open it up in our browser. And here we see a very clean and nice structure of all the diffs, so all the things that changed between revision A and revision B. So we see here, for example, this -1 function got removed and the +1 function got added. And here at the top we see that the new sub VI got added and an indicator got added. And you always see the pictures with the diffs, some text description, and what is also very nice is you can expand and shrink the sections here for a better overview if you have a lot of diffs. So with this approach we can make code reviews in the future much easier because we can simply view it in our browser. So we do not necessarily have to start LabVIEW, which is very great and saves us a lot of time. and there can be a lot of things that we automate in the future. So for example, what we did is we created these reports programmatically and added this to our CLI pipelines in GitLab, and at the end we can see the diff reports in our GitLab environment, which makes it very convenient to do code reviews. So this was a quick overview about the LabVIEW Compare tool. It actually got very useful over the last few versions, and we are heavily using it and integrated it in our automated workflows. So if you're interested in that and you want to find out more, please contact us. We have several workshops where we talk in detail about things like that, setting up repositories, building up automated pipelines to test software with the VI analyzer, doing unit tests, and at the end, building the software and deliver the software. So if this is a topic that is interesting for you, please contact us at LinkedIn, for example. Congratulations, you finished this mini course. I hope you had fun and learned a few new things, and it would be great if you could share this training on LinkedIn. This helps us to reach more people and produce additional content. Thanks a lot, see you next time.